In today's lesson, we're trying to discuss some properties of exponents and logarithms. First, properties of exponents. First one, b to power x times b to power y is equal to b to power x plus y whenever these are defined. So it's b bigger than 0 and b not equal to 1. And so looking at this logically makes sense. If I multiply b, let's say x is integer, and I multiply b and x times together, that's this first one, and then I multiply b y times together, then I have multiplied b x plus y times, and that's the third one. So this times that should make the third one. If x and y were integers, then the b to power x would be b times bx times divided by b times by times. And then in this case, if we can simplify, we can simplify y mini from the top and get x minus y. One way is if y is smaller than x, that's the one that we've been doing throughout the grade school. If even y is bigger than x, it still works. In any of these cases, non-integer values also work. We're just discussing the integer values to make to have a way to memorize these. B to power x to power y, exponential to another exponent, then exponents multiply. B to power 0, and we know that any number to power 0 becomes 1. B to power 1 is just b. If you have the base, two numbers for the base, product of the two numbers in the base, then the product to power x is going to be each factor to power x. If you have a quotient of two bases to power x, then it would be a to the power x divided by b to power x. Now, these are the logarithmic properties, and they somewhat follow the exponential properties over here. Again, for that section, we always assuming b is bigger than 0, b not 1, a is bigger than 0, a not 1. Same thing in here. This one has a c also, so c not bigger than 0, c is not 1. Okay, rule number 1, log base b of m times n is log base b of m plus log base b of n. How does this relate to this side? Looks like it should be something, when I have the plus over here, looks like a plus over here. But what's happening in this side? So first of all, let's call this x, call this y. What is x? X is a number such that b to power x is equal to m, and y is a number such that b to power 1, y is n. Now, if I multiply both sides, I get b to power x times b to power y is equal to mn. And now, at this point, I'm looking at this side of the story. This is a number z such that b to power z is going to be equal to mn. Now, if I multiply these two sides and set it equal to these these two sides, I get b to the power x times b to the power y is equal to mn. According to this rule, b to the power x plus y is equal to mn. So we showed that x plus y is equal to z because the other side is equal to mn, and base to x plus y is the same as base to power z. Now let's do the second one. Let's call log base b of m to power n z and log base b of m x. What does it mean log base b of m is x? That means that b to power x is equal to m. What does it mean that log base b of m to power n is z? That means that b to power z is equal to m to power n. Now let's try to use power m to power n for the top part, and it becomes b to power x to power n is equal to m to power n. But according to this law, b to power x to power n is actually b to power x times n equal to m to power n. So b to power x times n is equal to b to power z. That means x times n is equal to z. It's interesting to see this, that the logarithmic properties come from exponential properties and they're completely related. We don't need to memorize that to be able to use these properties alone. So I continue and without explaining how the next ones are related to each other. Now, log base b of m divided by n is equal to log base b of m minus log base b of n. These logarithmic properties come in handy a lot, and also their sister properties of exponents come in handy a lot. One of the ways that I actually read this is log of a quotient is equal to log of the numerator minus log of the denominator. Now, let's go to property 4. Log base b of b is 1 because b to power 1 is equal to b. Log base b numbers 5, log base b of 1 is equal to 0 because b to power 0 is equal to 1. And the last one is log base c of x is log base b of x divided by log base b of c. I want to make a point out of it when memorizing the properties. Remember, when there's a division of the logs, it works on the base, and it doesn't work the same way that this property works. Okay. For the matter of memorization, let's go through them one time and try to explain what the law is or what the property is using just plain English. First law is telling you that same base to different power, product of the same base to different power, then powers add up. And this one is telling you the division of same power, different bases, then base to power the difference. This one tells you that the base to a power to another power, the powers multiply. Base to power 0 is 1. Base to power 1 is itself. This one, two different bases to the same power. then a product of two different bases to a same power, then the power it would be the product of each base to a power. The division of two bases to a power is going to be the first the numerator to that power divided by denominator to that power. Logarithmic laws actually read better in English. Log of a product, see this is log, inside is a product, is going to be the sum, so that's the sum of two things, sum of logs. Log of a power, it would be power of exponential, it would be power times the log of the base. And this one also, log of a quotient is log of the numerator minus log of the denominator, or it's the difference of the logs. These also are very direct results of the exponential rules that it doesn't need to be explained, but that's how we memorize those. And the last one is important, so we remember that log of the quotient is different from quotient of logs. Let's do a couple of examples here. What is 121 a to power negative 2, b to power 3, a to the power 3, c to power 1/4? Can we simplify this? First thing, I see there is same bases in the product and with different exponents. Same base, different exponent will go with this one. So 121 a to power negative 2 plus 3 b to power 3, c to power 1/4. Now, the next one, and this is going to be a to power 1. The next thing is that I see different bases and the product of it to a power. That would be rule number 6. So I get 121 to power 1/4, a to power negative, a to power 1 to power 1/4, and b to power 3 to power 1/4, and c to power 1/4. Okay. 121 to power 1/4 is actually 11 to power 2 to power 1/4, and I know the powers multiply by this rule, and so this is going to be 11 to power 1/2. This one, a to power 1/4. This one is b to power, I know the powers multiply. And the last one, c to power 1/4. And this one, the powers multiply to get 11 to power 1/2, or square root of 11, a to power 1/4, b to power 3/4, and c to power 1/4. Okay. The next one, square root, third root of 5 times 7th root of 5 is equal to 5 to power 1/3, 5 to power 1/7, and let's use the rules that we have over here. And that would be the first rule. The basis is the same, and we're adding the exponents. And adding 1/3 plus 1/7 is going to be 10 over 21. All these properties come in handy when you're in calculus or higher than calculus, courses that require calculus. Now, this one actually comes in handy in solving logarithmic equations also, and comes in handy when you're doing calculus. What is ln of x plus 1 plus ln of x minus 2? can I put this into one term? Combining ln's help isolate ln's. That's why it makes solving equations a lot easier. So let's combine these two. I go back and look. Here is log plus another log, and then the result is log of the product. So I can put in x plus 1 times x minus 2. And if you have an equation here, this side equal to something else, then you have isolated the log by doing that. And we're done with this one.